Good morning, friends. Let's begin our session. First thing is we have to connect to our Docker host. For that, we have different kinds of SSH clients. We are using here the MobiXterm. Open the MobiXterm. MobiXterm is now open. Click on session. Click on SSH. Remote host means the public IP address or the public DNS name. You can paste either this one or this one. Today, let's do this. Paste it here. Username is Ubuntu. After that, advanced SSH settings, use private key, browse for it. My private key is located in here. Click on OK. We are now connected to the Docker host. Now log in as the root user. Now, how to check the images? Docker image ls or Docker images. How to check the containers? PS-A. -A stands for all. It will show running as well as the exited containers. Exited containers means stopped containers. What we can do with the stopped containers? We can start them, we can remove them. Okay. Then we have seen different options. Few of the options we have explored. What are those options? We have seen IT for interactive mode. Okay, interactive terminal stands for. Then how do we name a container using -name option? -D stands for running the container in the detached mode as a background process. -E stands for passing environment variables to the container. We will see this. Small p stands for manual port mapping. That means we will choose the Docker port, okay, to which we want to map to the container port. Capital P means it is automatic port mapping. Okay, that means we don't choose the Docker host port, automatically a port will be opened. Then -V stands for attaching a volume. We will see that slowly. Then let's see some of the scenarios. We have seen how to run a Jenkins in the form of a container. For that, Docker run command. Docker run command will create a container from this image. And I want to name that created container as the my Jenkins. You can name whatsoever you want. I want to perform port mapping so that some reliability will come. That means I know on which port the Jenkins server will be running. This is 9090 port. I want to explicitly mention. If we use -P in its place, then a random port will be allocated and it will be mapped to the 8080 port. Okay, so I want to run this in the detached mode, and this is the image name. We have seen that. We have also seen this also. Now let's do a scenario. Start Tomcat as a container. Okay, Tomcat as a container. In order to start Tomcat as a container, what we should have already? We should have Tomcat Docker image. Either it should be there in our local machine or it should be at least existing in the public registry, that is hub.docker.com. And I want to name it as web server. How to name a container? For that, we will use -name and the container name. Then perform port mapping and run this container in detached mode. How to perform port mapping? Using small p, and this is the 8080 port is the port of the Tomcat. Okay, how do we know that? If you go to the description of the Tomcat image in hub.docker.com, you will know this, or else after pulling the image into our machine, then we can describe it. We will see that. So we want to port map the what we are doing in this case. We do this. This is our Docker host. Okay. Now our scenario is start Tomcat as a container. So for that, what is the Tomcat image? We have Tomcat or the Tommy. How do we know that? Docker search Tomcat. Okay, so this is the most widely used image, and after that, this is according to our requirement, we can use different things. See, this is we can customize this, right? Then what we are doing, we want to run a container and name that container as what? Web server. The container name is web server. Web server. This is what? Docker host. Docker host is what? The machine in which Docker is called, Docker is installed is called as what? Docker host. Now, Tomcat container. This is Tomcat container. Which image we will be using? Tomcat or Tommy? We are using Tommy. Okay. Then we must be knowing that Tomcat will be running on port 8080. Right. This is the port of the Tomcat. Okay. So we have to map to which port? Docker host port number we can choose. So here we are doing 7070. 7070. Now, if you do this, we will be able to access the Tomcat from the outside with what? With the public IP address of the Docker host machine. What's the public IP address of the Docker host machine? This is, and the port number is this or this port number. This is 7070. Okay. With this, we will be able to connect to the Tomcat. Okay, this is what. So here, this is the container name. This is the image name, right? So image name will come at the end. Okay. So now let's copy this command. Shall we run in the detached mode? Yes, we have to run this in the detached mode so that we will be able to execute the other commands here. Okay. Unable to find image because we did not use the docker pull command. So it is trying to find the image in our local machine. If it is not there, it will try to connect to hub.docker.com. From there, it will pull the image called Tommy and it will create a container. To that container, an ID will be assigned. Okay. And docker ps command is there. See here, container ID. If you see here, this is the container ID, full ID. If you see here, only the truncated version is given here. This is also fine. Even you can use the 2 or 3 characters also if they are unique. Okay. So what I mean to say is docker logs. Okay. Which container? This container. Either you can use this one, you can use this one, or else also we can use a few characters here because it is unique, right? If you have another container starting with 1284 and if you use 1284, conflict will come. So okay, you have to get the unique thing here. See, that is the thing I wanted to show. Now see docker ps. So the port is 7070. Now copy the public IP address. Basics only, nothing complex here. We should be able to access the Tomcat server. That is fine, right? So now let's move forward. Now start Jenkins as a container in detached mode. Name it as a dev server, perform port mapping. As simple as this, right? Then scenario 3, start Nginx as a container and name as app server. Run this in detached mode, perform automatic port mapping. How to do that? For automatic port mapping, we use -P. So detached mode -D, right? So the name of the container is app server. So this way you can name it, right? So now let's do this. Done. Docker ps command is there, so an unique ID will be assigned to that particular container. Then what we have done, we have performed automatic port mapping. That means, so a random port will be allocated. So see, Nginx will be running on 80, and we are mapping that to the Docker host port 49153. 49153. 49153. So we are able to connect to Nginx. Now here Docker exec IT. Okay, I want to interact with the terminal of this container, and what terminal? Dash terminal. See that prompt went to the container, and I know that cd etc. What is the nginx? Sorry, we are into Tomcat, right? Control PQ to exit from it. Docker PS Docker exec IT. You can use either the container ID or the container name. So this I want to execute. Say if you enter this, see it expects some argument. You will understand this during the Docker file cd etc. Something like nginx will be there. In nginx, not nginx. cd etc. Which folder we have to go to? Nginx folder. Why I forgot this. Many times I worked in nginx server. Nginx HTML file location. Yes, this is okay. If I go to this, cd to this path, so we have index.html. So this is the content that we get here. Now let's modify this content. How to do that? Let's remove that file altogether and let's write our own content. Now that file got removed. Now let's refresh this. See, it is forbidden because that is not found here. It will be looking for HTML index.html, right? So now let's write index.html. VI editor is not found. So what we have to do? We have to install it apt update. What we are doing things in the container. Now apt install Vim editor via index.html. Now here, if I'm not wrong, hi friends, our Docker classes. Now let's do this. Let's save this. Now we got this file. See, we got that content here. So this is what I'm trying to tell here is how to execute command inside the container, how to update the package repository, how to do something like we are doing in the Linux machine. Very simple. That's done.
Sorry, whatever you do the changes, in case if you restart the container, will it be available or it will be gone?
Let's see that it will be available.
Available.
Okay. Okay. Now let's see. I don't remember exactly. So what we are doing, you want me to restart Docker restart. What you want to restart this thing, right? I think that won't be available because when we are restarting, that is not available. Definitely it won't be available. So in order to avoid that, what we'll do is we will write the Docker file. We will customize using the Docker file. Okay. So I'm 100% sure that. Yeah, it is taking some time. not running. Docker PS 49154. See what got changed. All content is available. I think it will be available. Okay, so I'm also not sure it is available, but if we stop and restart the content, definitely it will be gone. But when we are restarting, it is available. That's fine. Okay. But what we do, we don't do the configuration like this as I did. Okay. If you want to have new content, what you will do, for example, we will be writing the Docker file and we will pushing our own content to the container from the Docker host to the container. In that case, that will be preserved, even if it will be there in the image itself. Okay, so even if you remove this, if you create a new container, that will be there because that will be coming from the Docker image. So here, once we stop and restart, this content is not going away, still it is preserved. Okay, that is one thing.
So mostly we don't go much into Docker container inside.
Yes, we don't go. Yes, we don't go inside. When we will go, for example, we may be creating Docker file. In that, we may be copying our files from the host machine to the Docker container, Docker image. In that case, once we create the container using the Docker, or if you deploy the same image into the Kubernetes cluster, you may be getting some errors. And in that case, what you have to do, you have to check whether the desired file is copied to the container or not properly. So that case, we will go into the container to troubleshoot the issue. And if you feel if that file is not existing, then we will take the other steps to copy the files properly to the Docker image. Got it?
Yeah.
This is then very simple. These are very basics. This is also done. We have performed the port mapping, Docker container less. That is also fine. So Docker run, we want to run my CentOS content. We want to name this so, and CentOS is the image. Okay, community enterprise operating system. Now let's talk about -e option. To start MySQL as a container, open interactive terminal, create a sample table. This is our scenario. How to do that? MySQL should be already there in the hub.docker.com. Okay. Different versions will be there. This tagging we will understand whenever we are creating our own images. Now, hub.docker.com. We go here. MySQL. See, this is the official Docker image. Click on this. If we use the Docker pull MySQL, okay, the latest image will be pulled. But in our case, what we want to have, we want to have the older one with the tag 5. Okay, it's not the version of the MySQL. Okay, it's the version of the MySQL Docker image. It's a tag of the Docker image. We will understand that. Now we are using this MySQL image and we want to run a container from this image. We want to name that container as MyDB. Okay, whatever the name you want, you can give. DevDB also you can give, or also database also you can give. -d means detached mode. -e means environment variable we want to pass to the container. So this container will be expecting environment variable called this one. This is the variable, and I want to give the value as Laxman, so that whenever I'm connecting to the database, I will be logging with this particular password. So only the new thing here we will learn is the how to pass the environment variable to the container using -e. E stands for environment. Now let's copy this.
Can we pass multiple environment the same?
Yes, we can pass multiple environment. After that, we have to write another e, and we will be writing another environment variable. Is that fine?
Yeah.
Yes, we can pass because this container is expecting only one environment, but there may be another applications which will expect other environment as well. So because we don't have this image locally, so it is trying to get it from the hub.docker.com
Laxman,
that we have discussed many a times.
hello.
Yeah,
Laxman, how can we know like what are the environment variables that we need to pass while running this Docker container? Will it be
developer will
documented
know.
somewhere?
Developer will know. Developer will know, and those who created that image will know. For example, if you go to this in this description, it will be given. Okay,
Okay.
we will be finding out. In yesterday we have found, now we have found the port number. By default, we don't know, right, on which port that particular application will be running. So if you go to this, if you go to overview section, see here.
Okay.
So we will be understanding that here. That's fine. So now a container is created for MySQL, Docker PS. I always use -a. MySQL, the container name is MyDB. Now let's go how to interact with it. So for that, execute into this. So if you are from database background, your database background, so you must be knowing this. How to connect to the database? I want to connect to MySQL database. User is root. Password. Password it will be asking. We will be writing the password, or else also directly you can provide the password here. Now let's do this. Do this. Password is what? Laxman. That is what we have provided. So your MySQL connection ID is 2. It is successfully connected. Now, if you are from database, then you must be knowing the database commands, right? So how to list out the databases? For that, show databases. This MySQL and PostgreSQL, the commands may be different. So these are the list of databases. 4 databases are there in this. Then how to switch to a particular database? So I want to switch to this MySQL database. For that, use MySQL. Here, my intention is not to teach you database, but how to interact with the database terminal once it is containerized. So database has been changed to MySQL. Earlier also it is MySQL. Now, how to exit from this? Exit. Exit, everybody know, if anything is not working, we use either exit or quit or queue. Very simple things. Yes, that is one thing. So these are running. Now, what I want to do, let's go the sequence. Now, how to stop all these containers, or how to stop and remove? For that, Docker RM forcibly I want to stop and remove them. This is the command docker psaq. Okay, this is docker ps-a. Docker image ls images still will be there. They're independent of the containers. Now, what we are doing generally till now, what we did, we have created a Tomcat server, or like say some front-end application is there. For that, one container is there. Some database is there. For that, another container is there. They're independently running. As of now, we have created 3 or 4 containers. There is no connection between them. They are independently running. But in real case scenario, what we do, this front-end application should connect to the database, right? So what we have to do, we should establish communication between various containers. How to do that? That can be achieved using 2 ways. One is hyphen link option. Another one is Docker compose. Okay, so in case of link, it is already deprecated. We have the network, but still we will see this. Okay, now what I want to now let's explore how this link will do. What this link will do. Now let's start to busybox container. What is busybox container? It's a lightweight Linux distribution. As simple as that. If you want to learn about the busybox, so go to up.docker.com. You can read about that feature also, or if you want to busybox container. What is busybox container? If you want to know. So the Swiss Army knife of embedded line coming somewhere between 1 and 5 MB inside, very lightweight. Okay, busybox is a very good ingredient to craft space efficient distribution. Combines tiny versions of many common Unix utilities. Okay, with tiny versions of many common utilities, single small executable. That's it. It's a lightweight. It's not as heavy as our Ubuntu machine. It's not as heavy as our Ubuntu container. It's a lightweight. It has some basic utilities in that. Now, let's run the busybox container from the busybox image. Okay, Docker run and let's name it as busybox1. Let's interact with it. Whenever we are interacting, it will directly take us to the terminal of the busybox. It is not found locally. It will try to get it from the hub.docker.com. See, we entered into the terminal, right? Now, let's come out of it. Control PQ. Docker PS GQ. Yeah, busybox1 is running with this image. Now let's create one more container. Okay, first let's not use this option. Let's create one more container on Docker run busybox2 and let's name it as busybox2 and interact with it from watch image busybox image. So now let's pick control PQ Docker PS 8. Now let's try to do one thing. Let's ping. Just we are slowly advancing. What we are trying to do, we want to establish a connection between these two. Why there is a need for connecting those two containers? Because, for example, if let's say if this is the front end container, if this is the back database, definitely this front end should be able to communicate with the database. How to achieve that kind of communication? How to establish that communication? That is what we are trying to learn here. For that, what we do is let's ping. So if we ping, if the ping command is working, if ping is working, then we can say that the communication one container is reaching the another one. Now let's go into the container 2. Exec IT busybox 2. We have to. Okay, if bash is not found, sh. This busybox will be using this lightweight things only, right? So it will be using sh. If you take bash, it has more features. So sh it is using. So why we will do this? How we will do this? We will learn in the Docker. But we will also run some default processes. There we will see. Now let's ping busybox1. Okay, what it is saying, bad address busybox1. That means this address is not found. This busybox2 is not able to ping this busybox1. That means they are not able to communicate with each other. How to establish that communication? And before that, I want to show you another key. Control PQ Docker PS here. Docker inspect command is there. Inspect busybox1. See, if you inspect, all the details of that containers will be listed out. ID, created date, path, aux, state, image ID, host path, we will learn many of these things. And if you come here, each container will be having its own IP address. IP address means internal IP address. We can't access that from the outside. We can reach them through the internal IPs. Now, if you see, This is the IP address of the busybox1. This is what IP address of the busybox1. Busybox1. Now inspect busybox2. If you see, this is the IP address of the busybox2. This is the IP address. See, they are different. Now let's go inside the busybox2 again. Now let's try to ping busybox1. Let's try to busybox1 with the container name. It's not working. Now let's see ping with its IP address. Okay. What happened here? This busybox2 is successfully ping the busybox1 with its IP address, but not with its container name. Now you may be getting, what is the need for connecting with the container name? Will that container name will act as the DNS? Yes. Container name, we should make it as a DNS name. We should not make it. It's not like we are making it. The Docker architecture is something like, okay, this container name will act as host name, and this container too will be able to communicate with this busybox1 only if they are in the same network. Okay, so IPs are in the same network, so they are in the same network by default. If you see that, they are in the same network. Okay, so that's why they are able to communicate with the IP address. But in the world of containers, there is no significance for IP address. Remember this statement. This IP address will come and go when we are scaling up and scaling down the container. We will see this concept in the Kubernetes. We will understand there. Okay, but this statement, please remember, in the world of container, there is no significance to the IP address, because initially you may be having 3 containers. As the load increases, we want to replicate to 10 containers. In that case, 10 new IP address will be coming. But how the load balance will come? IP addresses are coming and going. So we will relying on the DNS names only, local DNS name. So how to make it? Now let's do this. And before that, let's connect to busybox1 and try to connect ping busybox2. Ping busybox2. We are not able to ping, but let's try to ping busybox2 with its IP, and it will be connected. Okay, but how to make it through the host names? For that, we have another option called -link. -link command is there. Now let's explore this. So let's keep busybox1 itself like that as it is. Now let's remove the busybox2 docker ps docker rm f busybox2. We are removing that. Now only busybox1 is there. Now let's establish a link. Now how to establish that link? Docker run -name busybox2. I want to create a container called busybox2 from busybox docker image, and I want to link it with what? Busybox1. I want to link it with busybox1, and this is some alias name. Don't worry about that. Now let's do this first. What we are trying to do? We are trying to link this busybox2 with that of busybox1 container. Now we are interacting with it. So as per my statement, now this busybox should be able to communicate with the busybox1 with its host name. Ping busybox1. See, ping is happening, isn't it? So we are successfully able to ping busybox1 from the busybox2 with its host name. Now, what is its relevance? Now let's see that. Control PQ. Now prompt went to the Docker host. Now let's create a development environment using Docker. How? Let's start MySQL first as a container. Okay. So this we have seen already. Password are sending Laxman. Now let's Docker PS. Now let's remove all the images. Docker RMF Docker PS AQ. I have removed all the containers. Now let's create MyDB container. Copy this. I'm copying. You guys please don't copy. So please at least you type 1 or 2 times so that you will remember the things. Okay. Now this container has been started. Now let's create one more container called my site with WordPress image. If you are using this WordPress images, they should be there in app.docker.com. It will be there for sure. How to check? If you don't want, if you are lazy to go to app.docker.com, you can check here Docker search. What is it? WordPress. See that image is there. This is the name. Now let's create this container and perform the port mapping. Now if you see, we are linking with this MyDB. What is this MyDB? This MyDB is nothing but the container name to which we want to connect. We want to connect with this, so we are linking this container with this, and this is some alias name. Okay, this link we are calling it as the MySQL. Okay, now the image is WordPress. Now let's try to do this. It means what? Now this my site container will be able to communicate with the MyDB. This will become the host name. This will become the database host name. Now we should be able to access the WordPress on port 5050. If everything is fine. WordPress is now accessible. Click on continue. Welcome to WordPress. Before getting started, you will need to know the following items. One is database name. Yes, I know the database name. The database name is MySQL. Database username. Username is root. Database password. Database password is Laxman. Database host means what? Host means the container name will act as the host name. That is what I said, right? What's our container name? Our container, if I remember correctly, MyDB. MyDB is the host name. Host is now MyDB. These are the database details. Now, let's go. Database name is what? MySQL. Username is what? Root. How do I know that? Okay, go to MySQL. Root user. Okay, that is then root password is Laxman. Host is what? Generally, host is the what? Public IP address or the internal IP address if you are running this database into your private subnet. Right? In our case, host will be myDB. Table prefix. Let's keep this. See, all right, Spocky, you have made it through this part of installation. WordPress can now communicate with your this database. That is, now we are successfully able to connect to the database from the WordPress. How we were able to connect to this? Because we have established a communication using -link option. We have one more way, that is using Docker Compose to create the multi-container architecture. We have also network. We will also see that in the networking section. Then creating a LAMP architecture using Docker. What we will be doing here? We will create a container, MySQL container. We will create Apache container, and we will link this with the MySQL, MyDB container. Okay, then we will create another container and we will link with this container. So this way we will be creating the LAMP architecture. Now you
Where the
practice this.
database will be?
Database is this, right?
No. I mean, whenever whatever data the data it stays in that container itself, or MySQL container itself.
Yes, it will stay. Okay, but once that container removed, what will happen? Our data will be vanished, right? But we don't want to vanish our data. We want to keep that. For that, we have one more concept, volumes.
Okay.
We will see that very important concept. We will see that going forward. Let's create CI/CD environment where Jenkins is container is linked with two Tomcat contents. Very simple. Let's remove all the containers first. Now, see, created Jenkins. This is a Jenkins official Docker image. Now, perform port mapping, run in the detached mode, name that container as a dev server. This is the image now. Very simple. We have discussed many times. Now, if you see, it will be running on the 7070 port. Now, we need two Tomcat servers. One is for QA server and is for his prod server. How to create it? Just Docker run. Let's name that as QA server and -d-p. We are performing port mapping. We are using the same port for the Tomcat QA server. Then I want to link this with the dev server. And this is the image. And this is some alias name. If you don't give also, no problem. Now let's run this.
Sorry, I think the same when you create that MySQL, the alias is not necessary, right?
Not necessary. We have seen that, right? Not necessary. Now here also.
Then what is the purpose of that?
That means we can reach this dev server using either this dev server name or you can also reach this one. Okay. Then this is another thing. Just we are linking this with the dev server again. Okay, nothing much to discuss. Very simple here. So now if you go inside one of this server and you will be able to successfully ping the Jenkins. That is this one. Very simple. We have also seen how to access them using public IP address and the ports. Now creating a test environment. This is also very simple. So due to this, and because we don't use this in the real time mostly, because we will be using the Kubernetes, but just for an idea, I'm telling all these things. This is the link command, how we will be using. Here also what we are doing, same. So Selenium testing environment, creating Selenium hub container and link with two node containers. One node is Firefox, another node is with Chrome. Generally, we don't use this in the real time. So just I want to skim through it. Docker run, again, same command, nothing new. This is the official Docker image name. Okay, it is being built by the Selenium. This is the Selenium hub is the repository name. Then Docker run, we want to name that node as the Chrome. So this is the image. This is the image name. right? We will be finding that in the hub.docker.com. Then the next thing is Firefox node. So in testing, what they will do? They will test application in Chrome and the Firefox browser, right? So for that, we have to create an environment. In real time, we won't be using that, but this is how we want to link. All I want to tell here is how to establish a link between two containers that will be achieved through link option. Then all the commands that we learned till now are ad hoc commands. Ad hoc commands means what? Now let's say we want, let's say we have about 10 microservices. 10 microservices in the sense 10 containers we have to launch. This is one container, this is another container, this is another container, and this container is there, this one is there, this one is there, this one. Like we have multiple containers. How to establish, and definitely one microservice has to talk with the other microservices. How to achieve that communication? We have to link the container with that link option in the Docker command. If you want to run, if you want to link 15 contents, what you have to do? We have to run the 15 commands. And if something went wrong, you won't be able to establish the communication. That's why I said this won't be used in the real time. So, and that is not version controlled. We are just executing the command. Definitely we should have a mechanism to version control our files, to store them in the repositories. So what's the other way to achieve this multi-container architecture? That means how to establish communication among various containers. For that, we have another thing that is called as what? Docker Compose. Docker Compose that we will see later. Docker Compose, we will be having YAML file. We will write all the steps. We will write the images name for the containers. We will write the container names. We will write the ports. We will write the networking and all those things. But without understanding this volumes and networking concept, you won't understand this Docker Compose. So now let's understand the other concept called Docker volumes. Okay. Now, what's the Docker volumes means? Now, before understanding that, Docker RM icon, Docker exec, sorry, Docker run. I want to run a container. I want to name it as Ubuntu container. Ubuntu container. From which image? Ubuntu image. And what are the options? We have to interact with it. Right? Now, we are into the terminal. Now let's create our own directory. Okay, yap1. So here into it, let's create some file one. Okay, so now let's yap dot, let's say yap.py, some Python application. Okay, we have some, let's assume that we are writing some Python application. App.py, v editor is not found. We have to install it. Now let's not worry about that. Touch file 2. Okay, then now let's exit from this control PQ. Control PQ. Now let's go into the container. How to go inside it? Docker PS, Docker execute into it, Ubuntu container, bash terminal. Now C is our folder is there, yap1 folder. Yes, yap1 folder is there. Directory. Say we have our own, our files. That's fine. Now I will tell you what I'm doing. Docker, it should not be taught at this moment. Okay, so we will understand that after Docker volume LS. So I will tell you this later. What I want to do is, so now we have created files in our container, right? We have created our files. CD var lib Docker volumes CD this is related to that. Okay, now let's not worry about that. Docker PS, this is our container. So now we have Docker host. We are creating a container in this. In this Ubuntu container, in this container named as Ubuntu container, what we are doing, we have created some file, yap.py file, file 1 we have created, file 2 we have created, right? But containers are ephemeral. Why we can say ephemeral? Because we will scale out, scale down. When we are scaling out, new containers will be created. We will understand that in the Kubernetes. When we are scaling down, the containers which are there, those will be deleted. In that case, what happens? If this container is deleted, what happens to this data? Data will go away, right? Data will go away, but we don't want that to be happen. We have to preserve the data. We have to preserve the data. How to do that? For that, we have a concept called volumes. We have a concept called volumes. So this volume concept, Docker containers are ephemeral. That means they're temporary. But the data processed or the data generated by this particular container should be permanent. Let's say that we have hosted the banking application in the form of containers in the Kubernetes, right? So let's say few people have made some transactions today, or some people have opened the new accounts in the bank today, but these containers are temporary, right? So we are running the application in the form of containers, but there is a possibility that if the container is deleted, what happens to the data? Data will be going away. Imagine if the bank data is going away, how much chaos, bank will become bankrupt, right? So it's the biggest failure. How to preserve our data? That means what we have to do, we have to create a volume in the Docker host, and we have to attach this, we have to mount this volume to the container. We will mount this to a particular path in the container directory structure, so that whenever we create these files, these files will be also synced here and they will be stored here. Okay. These files will also be created in this volume. So even if this container is deleted, stopped or removed or whatsoever, the container can undergo, right? So if this is deleted, still our files will be safe in the host machine. This is the concept of volumes. So there are two kinds of volumes. One is simple Docker volumes, another one is shareable Docker volumes. Simple Docker volumes means these are for only single containers and other containers can't share this. In case of shareable volumes, other containers will able to share the volumes from the volume of the other containers. We will see this practically. Then simple Docker volumes means these are only used when when we want to access the data, even of the container is deleted. We will see that practically. And this data can't be shared with the other containers. And there are three ways in which we will store the files in the host machine. Okay, which files? The files which are created inside the Docker container are the files which are processed by the Docker containers. Those files we can store in three kinds of volumes. What are those? One is anonymous volume. One anonymous volume means we don't give any name to the volume. By default, some random hashtag will be generated. With that hashtag, the volume will be created. And we will name, and there is another kind of volume called a named volume, where we will give name to this particular volume, and we will recognize the volume based on that name, meaningful name we will be giving. Then we have another kind of volume called host volume or bind volumes. All this concept we will see tomorrow. This is for today. Thank you guys. If you have any doubts, you can ask me now.
Whenever you generate, whenever you create the container for operating system, Ubuntu or BusyBox, you are giving that options interactive mode, IT. But when you create those another Jenkins and all, you are not giving. Is it necessary to give -IT whenever we create the container whenever we run the container for Ubuntu? Operating system related container.
Okay, yes, that is necessary. We have seen that, right? If you are not giving that, what is happening? Docker run -name. Now let's remove this earlier one. Docker. Somebody is. Let me go to his question. Sujit, you are asking, have you muted? No, I didn't mute anyone. Okay, if I mute, I didn't mute you, Sujit. I don't know, it's problem from your side, I think. Okay. Srinivas is saying, thanks, Laxman. I have to go to office. I am dropping up. Okay, that's fine. Okay, let's remove this container. I will clear about doubt. Right now we don't have. Now let's create a container. Let's name it as Ubuntu. Ubuntu C, just to distinguish from the image name. Now I want to run this. I want to name this like this, and this is the image. Now if you see Docker PS, is that container running? It's not running. What happened to that container? It is exited. Why it is exited? Because we did not specify by design. There is no default application running. There is no default command that is specified in the Ubuntu Docker image. That's why we are not able to do that. So if you are specifying an option like we want to open the command bash terminal, if you want to use it, bash is a process, it will be running. So in that case, this Ubuntu container will open its bash terminal. So this process will be running, so it won't be exited. So in order to open the bash terminal, what we have to do? We have to interact with it. Okay, how to interact with it? Using -t interact option. So because this container is already there, it won't take that name. The container should be unique. So let's name it as C1. Now it's running. Now Control PQ, if you do this and see Control PS, this container is running. Right? We will see, we will understand this in the container. When we can customize this Ubuntu and we can run a default process in that when we go to the Docker file. Okay, so when we are
Okay.
creating our Docker images, we will do that. Okay. Others, any questions? Sujit, you can happily mute. I think it's problem from your side. Other people are also able to unmute and talk.
So for us to do the practice, maybe you can share that people who paid, you can share that the
Yeah,
list of
yeah.
comments.
Yeah,
Yesterday
sure,
I
sure.
asked
Today I
also, it
will.
was not given.
Yes, yes. Up to today's class, I will share you for sure by end of the day. Okay, please bear. Right. Thank you, friends. I hope nobody is having questions. And let me save this recording.